Welcome to my walkthrough for the OCR Higher GCSE Maths papers from the summer of 2023. It's the paper 6 today, which for them is the third of three, and it's the calculator allowed. So let's get on with it. Question 1, feel free to read it in your own time. I can't be bothered, not going to waste any of our time, just going to move straight on, get to the point. 3 words required for the mark. The groups overlap, the bars overlap, any words to that effect. Something along the lines of someone could be in 2 groups. Anything, keep it simple. Don't feel like you've got to fill any more space up. Let's do some proper maths. Question 2, rearrange to make u the subject. That means leave the u squared where it is and remove the plus 2as from both sides by taking it away. So v squared minus 2as. And you're nearly there. To get u on its own, though, you do need to square root both sides. So u will equal the square root of all that nonsense, v squared minus 2as. And that's enough to get the 2 marks. You may be one of those people, maybe your teacher does nag you that when you square root, you should be thinking about the plus and the minus. Mark scheme's fine with or without. No one cares. Not a big deal. Question B. A rocket accelerates at 90 meters per second squared. I'm a big fan in these wordy questions of writing down the obvious, so you've almost got like a menu to choose from. Acceleration equals 90 and travels 270 kilometers. That means our distance, which is the letter S, is 270 kilometers, but it wants the answer in meters per second. Straight away, get rid of the kilometers. The sooner you can work in the units that are required, the better. We times it by 1,000. So distance is now in meters. Then we've got the rocket's final velocity. Final velocity is the letter V, and that's 8,000 meters per second. Again, that's in the units. We're happy with that. No need to muck around. Using part A or otherwise, calculate the rocket's initial velocity. Well, initial velocity is the letter U. So nicely, they've led you through it. You just need to use your answer to part A. And I'll just say if you made a mistake on part A and it follows through correctly, you do get all 3 marks, not a problem. If you use an alternative technique, a different formula, a couple of different formulas even, and got there in a roundabout way, again, 3 marks are yours. But also take on board the lesson that just because you can't do part A doesn't mean you can't do part B. So if you fail to rearrange it, you simply subbed into the original equation, then rearranged it. It's fine, but never in an exam let the fact that you struggled on an early part stop you from getting any marks on a later part. Just get on with it, sub numbers in and see what happens, you never know. So let's stick them in. To get our initial velocity, we'll be taking the positive root. We need to do v squared. I'll have to squeeze it in a little bit because the numbers are quite big. It'll be 8,000 minus 2 times 90 times the 270,000. And you stick it all in your calculator. I end up with 3,924.283, whatever horrible long decimal. Excuse me. We'll call it nearest whole number. Keep it sensible. 1 mark for correct usage. Maybe trying to get your units correct, or any decent attempt to sub in properly. Any great attempt to substitute all the values in, and then obviously 1 for your final answer. Number 3. Some of you just call it experimental probability. Some people call it relative frequency. They are the same thing. Different books, different teachers, same thing. Anyway, bag contains 150 counters. They're either red or yellow, and there's Riley's results. So as you can see, in Riley's results, got 5 red, 4 yellow, 9 in total. Use Riley's results to work out how many red counters are likely, because this is estimate, educated guess, how many are likely to be red. Well, based on Riley's experiment, 5/9 of means times, and there you go. 1 mark for 5/9, 1 mark for multiplying by 150, and you get the strange answer of 83.3 recurring. I would always round that down to 83. Mark scheme does accept 84, but nothing else for your 3rd mark. Question B. Ling uses the same bag of counters, get that information. Again, I like to write out what we've got. Ling's getting 12 red, 8 yellow, and has done the experiment 20 times. Use Ling's result to estimate the probability of choosing a red. There are 12 red out of 20 for their experiment, so that's our best estimate based on Ling's data. Simplest form, cancel it down, divide everything by 4. We get 3/5 for your 2 marks. Part C, very standard, comes up all the time. Explain why Ling's results are better than Riley's results. And again, just like question 1, keep it simple. Ling's done more. Not the greatest English, but Ling's done more. Ling has more results. Riley has fewer results. Riley's not done the experiment as many times. Any simple word or phrase to that effect, referencing that Ling has done the experiment more times than Riley. Don't waffle or overcomplicate. Question 4. The time taken to complete a journey halves as a speed doubles. Now, if you aren't aware of this type of graph, if you're trying to do it from memory, just think about this. That means if you've got some data, the time taken halves, so it halves as the speed doubles, halves as it doubles, and it should build up a picture. But hopefully you'll already know that that's your good old reciprocal graph. You get 1 mark for the correct shape and 1 mark as long as it doesn't do anything stupid, and stupid would be something like touching the y-axis or touching the x-axis. It shouldn't intersect, shouldn't brush, should not be anywhere near. Keep it like mine and you'll bag the 2 marks. Question B. It takes 40 minutes to fill a garden. Use garden pond using water from 5 hose pipes. Stop right there. That's a total of 200 minutes filling time, or whatever the heck you want to call it. Assuming the rate of flow from each hose pipe is the same, work out how many minutes for 2 pipes. We divide our answer by 2, and it's a really nice, easy 100 minutes. Nothing trying to catch you out there. 1 mark for 200, 1 mark for 100, and just move on. I'll do a quick little edit there because I forgot to cut and paste this from my worked answers, but here we go. So question 5, diagram represents a coastline, and basically grab your ruler and compasses to construct the following. A boat is the same distance from A and B. There's lighthouse A, there's lighthouse B. In order to be the same distance from 2 points, that's a perpendicular bisector. Whether those points are joined up or not, your job is to construct perpendicular bisector at a right angle. Just to very quickly recap, that means set your compasses over halfway, put the metal point on one end, and draw roughly a semicircle. Pick up your compass, back on the other end, don't adjust it, draw another semicircle, and then you've get your ruler, you've got your perpendicular bisector, So the boat is somewhere along that line. Second part, to be the same distance from AB, let's change colours here. To be the same distance from AB, you would need, let's grab a red, there's AB, then BC. To be the same distance, this is now an angle bisector. So again, grab your compasses, put your metal point at B, and mark an arc to one side. And I forget where it is, it's obviously slightly disappeared under. Mark an arc from the other side. Then pick it up. Again, repeat metal bit on here. Draw a little arc. Metal bit on the other. Draw an arc. And you've got your angle bisector. And where they meet is where the boat is. Also, apologies, on doing my walkthrough videos. I'm always a bit rubbish at having to do these, so hopefully, you can find a good video out there. They are available. Maths Genius got a good one, Corporate Maths on how to do constructions. Go to those. Their technology much better than mine, but there we go. It's basically a perpendicular bisector for phase 1, and it's a angle bisector for part 2. On to number 6. Let's get my colour back. Let's go back to blue. So a bit wordy, bit waffly. At the end of each year, a driver records how many kilometres they have driven. And it's one of them which is a little bit all over the place. I wouldn't say they've given it in the best order, but that'll be by design. So when you get to part B, be careful. It's kind of needs a bit more mapping out. But part A, not too bad. Part A, we've got Kai. I can work out how many kilometres were driven in 2020. In other words, Kai says we can work backwards. Working backwards with percentages means reverse percentages. Kai's basically saying, there's 2020. We have a multiplier of 1.25 because it was a 25% increase, and there's his problem. He's multiplied by 0.75 what he should have been doing. What they should have been doing. So just write it. I should have divided by 1.25. That's how you will have done a reverse percentage for when it's been a percentage increase. Right, now part B, as I say, this is a bit messy for me. So the way I did it is lay out the story. There's 2020, there's 2021, and there's 2022. I put a ring around them because they're not numbers we're going to use in our calculations. There we go. This line, in 2021, they drove 18% more than 2020. So from there to there, that will be 18% more. Then, next line, in 2022, they drove 25% more than 2020. So if you want to go that way around, that would be a multiplier of 1.25. That's if you want to go that way around. Calculate the number of kilometres in 2021. That's really what we're trying to do. Well, let's just go back to the third line down. In 2022, they drove 3,500 kilometres. We need to go first of all that way, which is against our arrow, to 2020. Against means inverse operation. Then we need to go with the times by 1.18. So we can multiply at that stage. So getting them in the right order, getting your story mapped out is extremely important. All right, you get 1 mark for multipliers, 1 mark for using divide by 1.25 and 1 for timesing. and your final mark should come out at 3,304 kilometres. Number 7, we have an upside down x squared graph. That's a negative x squared graph. Now it says show that k equals 3. Let's just bring it down. So k is the number in front of x squared. I always prefer to write it in the order it should really be. X squareds, x's, and constants. Show that k equals 3 means you need to pick a coordinate from the graph. There's actually quite a few coordinates you could pick. All right. For example, a good coordinate to pick is 1, 4. It does go through the coordinate 1, 4. X equals 1 when y equals 4. Another one, but not so useful, is really 0, 2. And the problem with that is if you sub in x equals 0, the k term disappears. So I wouldn't be going with that one. It doesn't help you out. As I say, there are others you could pick, but I personally wouldn't bother with any decimals or any rubbish like that. It's much easier to substitute in whole numbers, and 1, 4 is definitely the best option. Let's take these values for x and y, substitute them in to this equation. Replace y with 4, replace x with 1. We've got 1 squared, got to follow BIDMAS. We've got 1 squared, which is 1, minus in front of it, plus x times k is 1 times k, plus 2. And you're nearly there. You've earned a mark for method. You now just need to finish off the job. If you add 1 to both sides, subtract 2 from both sides, you end up with, as asked for, k equals 3. For you, showing it clearly for your mark, make sure you might say, should I actually show that line? Mark scheme's not that specific, if I'm honest, but personally, I would. So why not? It doesn't take you that long at all, does it? Part B, you've got the exact same graph. You might go, oh, it's a bit different. No, it's not. They've simply put the value of k in. That graph there is the graph that's drawn. It's now got k equals 3, except we now need to put it equal to 3. How do we do that? That means you need to draw a horizontal line through 3, because you're essentially solving simultaneous equations. Once you've drawn your horizontal line that equals 3 for there, then you read off your data, grab a ruler, because it's asking you, oh, my snap 2 things are way out on that one. Let me just adjust it. There we go. Go down to your x-axis to read off one answer. Go down to your x-axis to read off another answer. Now I'm doing this on my electronic pen and stuff, so answers not as accurate as what I've done. Really, the answers I came out with on my worked answers, I got 0.4 and 2.6, and they are what the examiner is looking for. If you've got it slightly out, as in 0.5, let's say, and 2.7, that's when they check to see where you've drawn your line. If they spot a mistake, they will take a mark off. If they don't like how you've drawn your line, or you've done the old, oh, I followed it with my finger. Rubbish. Don't get those marks, folks. Show your method, then you get the follow-through marks. If your answer differs, you'll be fine. Number 8, bit of a weird one, this one. Quite a strange way of explaining one particular concept in terms of rotational symmetry. So Taylor's doing a design like that, the key bit being, if it has rotational symmetry of order 60, that would mean that there are 60 of those triangles. There just has to be. More importantly than that, if there's 60 of them, and they have rotational symmetry, they will fit around a point. That means each little angle down the bottom will be 360 divided by the 60 to give a very small angle of 6 degrees. Let's take that forward. I'm going to redraw this diagram, but only half of it. It doesn't have to be accurate. They've marked H as the height. Be careful, it's not the hypotenuse. They've got B as the distance all the way across the bottom. B is 40. We've halved it. It's 20. Height is perpendicular to base, so we can put the right angle in there. And as stated before, that's a 6. Yep, they've managed to hide SOHCAHTOA in a rotational symmetry question. But hey, there we go. The hypotenuse is not being used. It's an O and an A question, which means it's TOA. We are trying to find out this side, which is the opposite. We need to press on our calculators tan of our angle multiplied by the adjacent side. And if you don't get 2.102, rounding off to 2.1, do make sure that if your calc has opened the bracket, that you've closed it as well, because that's a very common mistake. As always, SOHCAHTOA definitely gets 2 marks, sometimes 3 if it's a standalone, but you'll get 1 mark for working out 6. You'll get 1 mark for TOA, and there's your 4 marks. Number 9, Heidi's bookcase. The ratio of fiction to non-fiction is 2 to 3. Stop right there. I'm not a fan of ratio or wordy waffly questions like this, where the information is horizontal. It just doesn't look right to me. I much prefer to go fiction, non-fiction, 2 to 3. Heidi removes 2 fiction books. So hold on. We don't know how many they've got. What we do know is that it's a multiple of 2 and 3. I'm going to call that multiplier K. So we don't know how many fiction books we know, but we know it's a multiple of 2. We don't know how many non-fiction books, but we know it's a multiple of 3. Heidi removes 2 fiction books. That means she's got 2K minus 2, while the non-fiction stays the same. The ratio of fiction to non-fiction is then 5 to 8. We've done the heavy lifting, really. We're only interested in making a connection here. The idea being, now if we just simplify this for a bit, if it was 2 to 3 and we scaled them up to get 4 to 6, it is no coincidence that 2 divided by 4 equals 3 divided by 6. They are indeed the same, and you could argue with ratio the other way of looking at it, 2 divided by 5. Alright, 2 divided by 5 is the same as 4 divided by 10. 2 divided by 3 is the same as 4 divided by 6. There's lots of ways in ratios of connecting the next stage. So whatever you've done in class, stick with it. For me, I prefer to say that the 2k minus 12 so the left-hand side divided by the right-hand side will be in the same proportion as the left-hand side divided by the right-hand side. We've set up an equation. We've earned a couple of marks already because of our expressions. We now need to solve it. I'll multiply both sides by 8. I'll multiply both sides by 3k. That's meant to be 16, by the way, but you know that. We will add 16 to both sides. We will subtract 15k from both sides, and we know that we've got the value of k to be 16, but be careful, the answer wants the total number of books. Let's go back to here, because the total number of books is 5k, and don't forget, Heidi removed 2, so take away 2. Calc or mental arithmetic, it's entirely up to you. As long as you get 78, you can get moving on. Number 10a. Show that 95 is not a prime number. Loads of ways of doing it. You've got a calculator. Feel free to list all of its factors if you wanted to, but for me, much a bigger fan of keeping it simple. 5 times 19, it ends in a 5, it'll divide by 5. Mark scheme accepts that as a minimum. If you've explained more, that's on you. Entirely up to you how much more waffle you want to do. I don't. B part I. It's one of those questions where they've given you the numbers. You would normally expect to have to do factor trees for these, but they've done them already. So if you are a person who draws a Venn diagram, that's fine. But when it comes to HCF, you're only interested in multiplying what they have in common. We look at the 2's, 2 to the 4 and a 2 to the 1. They've only got 1, 2 in common. The 7's, nothing in common. That'd be over there and no there. And what they got in common in terms of the 5's, they've got 3 5's, 5 cubed in common. That's what you need to multiply for your HCF. Grab your calc if you need to. 2 times 125 is 250. Question double I, bringing in a bit of standard form. The idea being another way of writing 10 to the power of 12 is you can replace the 10 with 5 times 2. Now, if you analyse that closely, that really means if you wrote that out in full, 5 times 2 times 5 times 2 times 5 times 2, and so on 12 times, you'd have written 5 down 12 times and 2 down 12 times. 1 mark for breaking it up, but don't forget, there's an extra 2 in the question, meaning your final answer is 2 to the power of 13 times 5 to the power of 12. And there you go. So just breaking it down a little bit further, 5 2's is your key. Number 11, we've got a trapezium. They've called it a quadrilateral, but we know it's a trapezium because of the 2 right angles will make those parallel. Okay, so that's your first thing. They tell us that PS is 10, don't care, and those angles are 90, don't care. That's more waffle than they normally give us. It's all on the diagram. Here's the key bit. S to R is 6 longer than P to Q. As with a lot of maths, let something equal X, and then you can write something else down here, in this case, X plus 6. The area of the quadrilateral is A. Write a simplified expression for the length PQ. Yeah, not the most friendly in the world, a little bit strange. Let's just have a think. The fact that I started off saying, oh, 2 right angles, they've told us it's a quadrilateral. They're keeping the information from us that it is a trapezium. You're the one that has to suss that out and realise that the area of a trapezium is given by adding together the parallel sides and halving them, but then multiplying by the height of the trapezium, which is the distance between the 2 sides. Let's get rid of this. In the brackets, we have 2x plus 6. And outside the brackets, we've got half times 10, which really means 5. So let's just multiply what's in the brackets by 5. All right, we get 5 times 2x. We get 5 times 6, like so. And it's, as I say, write a simplified expression for the length of PQ in terms of A. The length of PQ we've called X. So first of all, let's subtract 30 from both sides. And then let's divide everything by 10. But X is indeed the length of P to Q. Now the mark scheme, yep folks, that's fine as an answer, but it isn't fully simplified for me. So it does say write a simplified expression. I would write it, and the mark scheme does prefer it. It's A over 10. They're just splitting it up because the bit that's not simplified is 30 over 10, which is really 3. So you're up to 4 marks there, but because it wants a simplified expression, the fact it's got 30 over 10, that's not as simple as it should be. So a couple of marks for coming up, correct use of formula and using it correctly with the correct values. The x and the x could be different. You could have done x and x minus 6 and so on if you'd have looked at it from a different perspective. 1 mark for good algebra, but there's your 5. On we go. Number 12, part A, errors and bounds. I'm afraid this one is not, it's designed to catch you out a little bit, unfortunately, because most people will be used to, if something's rounded off to the nearest 10, you simply add on half of that. So you add on half and you take away half. We go down to 195 and up to 205. I'm afraid not. The 195, that's correct. It's because number of matches, let's go back to your year 7 knowledge, they would have called that discrete data. You can only have a whole number of matches. If it was measurements like heights, widths, or whatever, then you can fall into the category of the old 0.9 recurring, which is near as damn it as 205. Not when it is discrete data. You can't have a decimal amount of matches. It must be an integer value. So think about what is the most number of matches you can have in a box before it starts to get rounded up. And it's 204. Because 205, that would round up. 205, as we've said, if you did write 205, that's only correct when 204.9 recurring is correct, and it's not, so it's not, so I'm afraid not. Question B. The box is a cuboid, and there we go. I'll let you read them out. I'm not going to read them out. Length, width, and volume. Show that the smallest possible height is 6. Now the idea being, let's start off. Volume of a cuboid is length times width times height. We are wanting to rearrange it because we're interested in the height. We want to write this as height, and I'm just going to space it out a bit more. Height will equal volume divided by length times width. But now let's add on that bit of logic. To show that the smallest possible height means we're looking for H minimum. How do we rearrange, or how do we write numbers in this calculation so that we get the smallest possible answer? And the only way we can get the smallest possible answer is if we have the smallest possible volume divided by the largest possible lengths and widths multiplied. And there we go. So volume minimum, volume is 248, nearest centimetre. We want the minimum, we go down by half a centimetre, because this is discrete data. All right, so, but not that that's going to make a difference here, but it is discrete data because it's now measurements. But it's 247.5. The maximum possible length is, well, the length is 7. It's the nearest centimetre. We need to go up and down by half. This is where you could have got 7.49 recurring and so on. But if you type 7.49 recurring in your calc will just really think, why didn't you just press 7.5? And obviously you can't put in your millions and billions of nines in there. You just put 7.5 for convenience sakes. And same with your width. The biggest possible width is 5.49 recurring. Again, best off using 5.5. And when you get all that into your calculator, believe it or not, it does spit out 6 centimetres, shown quite clearly. It's 3 marks, 1 for a decent formula, 1 for any 2 of your boundary picks being correct, and 1 for demonstrating and showing it crystal clearly. On we go. Question 13. We've now got a histogram. Histograms are all about areas, frequencies and areas. Problem is, to find areas, you need to know heights, and there's no markings. So that's going to be your first problem. So waffle at the top, forget it. 18 members run less than 20. The area of this bar is 18. We need to do area 18 divided by width 20 to give us the height. Comes out at 0.9. So a little bit of looking at the y-axis here, you'll be able to see that what that means is every 2 squares is 0.1. Every 1 square is 0.05, meaning that's 0.51. 1.52, and we're not that bothered about the top one. It says 18 members run less than 20. Done. Work out how many of the members run more than 30. More than 30 will be this region here and that region there. We need to work out the areas of these regions and add them together. The first one has a width of 10. And a height, if you read it off, its height is bang on 2. This final bar here has a width of 40, but its height is actually 6 squares, which is 0.3. Get all that into your calc for 32. You'll get a mark for the correct vertical axis up there. You'll get a mark for method and a mark for answer. Finley says, to estimate the range, I subtracted the smallest possible from the largest possible. Now, if you look at the data, he's got a point. The smallest possible is indeed 0, because that's where the lowest bar goes down to. And 80 is the upper limit, that's where the highest bar goes up to. But explain why Finley's method is likely to overestimate. So you need to take either the upper or the lower, and simply say that the true highest will probably be under 80. I've said the phrase, the longest could be anywhere from 40 to 80. The longest could be 41. Very, very, very unlikely, but it could be. So you need any phrase to say, well, from the other side of things, the lowest is not guaranteed to be 0. It could just as easily be 10. But it's almost certainly going to be an integer of 1 or above. So just get to the point quickly. My personal preference is the longest could be anywhere from 40 to 80, and that's enough for the mark scheme to give you that mark. Part B, we've got a box and whiskers plot. That shows the distribution of the distance run by each member of the running club during July. So the previous histogram was all about December. During December, the median was 30. Stop right there. If they're giving you the median for December, you need to read off the median for July, which comes out for us at 26. The interquartile range was 20. Again, stop for a sec. Interquartile range for us is what? 54 minus 18. For us, IQR is 36. You're going to pick up a mark for that information, but best to use it in your justifications down here. Make two comparisons between the distances running. So like with all these waffly questions, I've done it as I would expect you to present it. I've done my worked answers, posh way, how I'd like to see it. Here, I'll just describe it to you. Phrase 1, I would simply put, always start with on average. On average, July distances were lower, or December distances were higher. And it helps if you get in a comparison of the median. The median of 26 is lower than the median of 30, but just keep it simple, get to the point. 1 mark for statement, 1 mark for use of those numbers, or getting them in somewhere either here or on your diagram. Another one, do measure of spread. So I simply put the July distance, they were more varied. And that's because the IQRs were 36, which is much bigger than 20, which is what the December IQR was. Again, 1 mark for statement of more varied, or December shows less variation, and 1 mark for comparing the data. Number 14, the diagram shows a square base pyramid, ABCD. Draw a plan view. Plan views of objects are where you are viewing it from a helicopter. It's from the top down. We're told to use the scale. 1 centimetre is 4 centimetres. Look at your diagram. That means these edges like BC, they're going to need to be 5 centimetres on that grid, so 5 squares. Grab your ruler. When you look down on a pyramid, it's a square. So width 5, height 5. Finish off the square. For a square, you get 1 mark, because what else you see are the slopes. You see the ridges, whatever you want to call them, you'd know they were there. And that's what you look down on. So as I've said, 1 mark for the shape being a 5 by 5 square, and 1 mark for those ridges. On part B, calculate the volume of the pyramid, and they've given us the information there. Now, the easy bit is the 20 by 20 base. The volume of a pyramid, let's write it with some space. The volume of a pyramid is 1/3 times the area of the base, which is 20 squared, multiplied by the perpendicular height, A. We do not know the perpendicular height. The perpendicular height is the height from E down to O. We do not know that. What we do know is we've got 14.5 on the slope. We've got 20 around the side. In order to get E to O, we would need to know another line, because we know A to E is 14.5. We don't know what AO is. So we need to, first of all, take a bit of an interest in the base which is a square, because we're wanting the distance from there to there. Now it's 20 by 20, but we halve it because it's the midpoint. We've actually got a 10 by 10 little right-angled triangle. We need to apply Pythagoras because from A to O, it's the hypotenuse. We must square root 10 squared plus 10 squared. You've got your calcs, and most calcs will prefer to work in surd form. That's fine. We've earned a mark. Back to the diagram. So we've got the distance AO. A to O is 10 root 2. Let's now consider the triangle I've drawn in blue. AOE is a right-angled triangle. Let's have another drawing of it. Always makes looking at a problem a bit easier if you slightly change the perspective. So we've got A to E, which is the slant of 14.5. We have the perpendicular height, which is E to O. And we've got this third side here, AO. That's the 10 root 2. So yeah, it's double Pythagoras. To find the height is not the hypotenuse. We need to do slope the hypotenuse squared minus the 10 root 2, or the decimal equivalent, squared. Again, most calculators will work in surd form, should spit out root 41 over 2. Mark scheme, by the way, you're picking up a couple of marks for this bit of Pythagoras. But now you've got your H, your perpendicular height, you can now get back to working out the volume. Grab your calculator, stick it all in one go. Should be getting 426.87-ish. I'm going to call it 426.9 to 1 decimal place. You're obviously getting a mark for using that formula correctly and a mark for the right answer, given in any degree of accuracy you see fit. Number 15. When it says similar, it really means there's a multiplier that relates the two. I like to set these questions up. It's not the most waffly or wordy in the world, but I still follow the same process of going, right, we've got small, we've got large. When we are talking volume, the small bottle holds 0.5 and has a height of 35. The large bottle holds 2 litres. Stop right there. That means there is a volume scale factor of 4. Volume is working in 3 dimensions. Height is working in 1 dimension. To go from your volume scale factor to your linear scale factor, you must cube root it. And that's what you type on your calculator. You've now got 35 centimetres. You multiply it by your scale factor, and I'm getting 55.559-ish. I'll call it 55.6. 1 mark for scale factor, 1 mark for cube rooting, 1 mark for multiplying by it, and 1 for, again, giving your answer in a format that you see fit, that is sensible. 4 marks done. Number 16. We've got the price on a seat. Now, there's a little trick in this question, so just be careful. The price of a seat is given by that formula, P equals 49 multiplied by 1.009 to the power of n, where n is the number of seats already sold. So just to mention that, that means when you get to, for example, the 10th seat, If we're looking at the 10th seat, there's only 9 seats already sold. And that comes into play on part B. Anyway, write down the percentage increase. The percentage is always the bit at the end. It's the 0.009, but that is as a decimal. We want it as a percentage. It needs to be multiplied by 100. The percentage increase is 0.9%. But now comes that pain in the bum, part B. Show that the price of the 40th seat. Back to your formula, except you need to be using the power of 39. Now, if you use 40, it does just sneak over 70. So that should be a clue that 40 is incorrect. Although it says 40 in the question, no. Selling the 40th seat means 39 have already been sold, and you get £69.49. And who cares what else? Because you get 1 mark for using 39 and 1 mark for doing it. As I say, if you did fall into the trap and get 40 there, it goes over 70. That's where you need to rethink what you're doing. It's not quite right. Number 17, non-standard. Doesn't look great, not as bad as you might think. The kth term of a sequence is r to the k. So in other words, the sequence goes k to the 1, k squared, k cubed, and so on. The 6th term, write it down. The 6th term will be r, oops, I've written it wrong. It'll be r to the k. So the 6th term will be r to the 6. The 2nd term will be r squared. And they are equal so long as we are doing 3 times the 2nd term. Couple of ticks, you've set it up. We need to divide both sides by r squared. Find the value of r, giving your answer correct to 3 decimal places. We know what r to the power of 4 is. We need to get you at that root button on your calc where you can put in the 4th root of 3. Normally looks like that on most calcs. If it's different to that, I'm afraid you'll need to find it out yourself. Ask someone who knows, ask your teacher who's more familiar with what you've got. But there we go. Stick that in, and I get 1.316 and a load of other nonsense. We want 3 decimal places. It's followed by a 0, so it just levels off to 1.3. Whoops, 1.3. Come on now. 16. And on we go. Number 18. Describe fully that graph. When you've got x squared and y squared, folks, state the obvious. Hopefully you've seen it before. That's a circle. 1 mark. Its centre, because it's not got any x plus 1, x minus 1, the centre is the origin, or 0, 0. And the radius, or just r equals, is the square root of whatever is on the right-hand side. And you could have written that as 2 root 5 if you wanted to, but it's entirely up to you. 1 mark for each bit of info. Part B, the graph of y equals 3x plus 10 and x squared plus y squared equals 20, they basically intersect, which is a waffly way of saying solve these simultaneous equations. I'm going to stick with the x squared plus y squared, except I'm going to replace the y with 3x plus 10. And then, how on earth do we solve these? We get them in quadratic, we expand the bracket, we collect like terms, we make it equal to 0, then we solve it. So let's crack on. X squared, square the brackets, whoops, not an equals. means square the first, square the last. Whoops, it's not 10, is it? It's 20. I'm sure you spotted that. And we'd get 30x and 30x to make 60x. Now let's make it equal to 0. So we've got x squared and 9x, that's 10x squared. Let's bring the x's to the middle. We've got 60x. Then we've got the 100. We need to take away 20. And you could use a quadratic formula at that point, but when they're all in a certain times table, get them smaller, divide them by that common factor. And then sometimes, and as in this case, it's an easy one to factorize. X plus 4, x plus 2, meaning your two x ordinates are -4 and -2. You just need to work out the corresponding y ordinates. As we know, y was equal to 3 times x and then plus 10. And y was equal to 3 times x plus 10. Grab your calcs if you need to, but 3 times -4 plus the 10 is -2. Make sure you pair them up correctly. And 3 times -4 is -6. Add 10, you get to +4. 6 marks, 1 for eliminating, 1 for replacing, 1 mark for correct manipulation, 1 for forming a quadratic to be solved, 1 for solving it, and then it's all about the answers from there on. Mark scheme gives you a variety for using and subbing in and all that malarkey. I'm just easy to say 1 for each correct pair. On we go. We've got surds. We're going to just show that. Well, to show that, rewrite root 22 as root 11 times root 2, and you're done, because 11 11s are 121, and you've done. You didn't need every single bit of that. You could have got away without that bit and just gone straight there. But me personally, it's a show question. I would include that bit, but that's a personal preference. Part B, we're rationalising. That means multiplying top and bottom by changing the sign of the denominator. We need to multiply by 13 minus root 22 all over 13 minus root 22. Mark for method. We now do top times top. Root 11 times 13. Root 11 times root 22. We've actually already done. And it's a minus. All over 13 times 13 is 169. Root 22 times root 22 is 22. And it's a plus times a minus. You do not need to do the other things because they will cancel out. And all this simplifies the denominator, simplifies, but it doesn't simplify any further. Always have a quick check of what you've been given at the start. And as you can see, it needed us to write it in the form of a number in front of root 11. We've got a number, minus 11 root 2, which we've got, and B on the bottom just happens to be an unfamiliar number, 147, but it is the right answer nonetheless. And finally, a very much non-standard way of basically getting you to complete the square with a tricky, completing the square because there's a number in front of the x squared. A couple of reasons why it's tricky is indeed, first of all, yeah, you're going to have a number in front of the x squared and they've given it you in an unexpanded form. So first job is to remove the brackets. Do all your loops, do your grid, whatever you need to do. 2x squared plus 8x minus 5x minus 20. Let's get it simplified. Bring our x terms together. We get plus 3x. And we've got minus 20 on the end. So that 2 is not how we like it. Get rid of it. Take it outside. I like to open square brackets. Leave the minus 20 alone. You can come back to that. When you take a 2 out, each of these terms must be halved. Now, because it's a calc paper, I'm going to go into decimals. Halve the 3. If it was non-calc, I'd be going 3 over 2, because as a fraction, without a calculator, it's easy to square it and stuff like that. But because I've got a calc, go into decimals, not a problem. Now we need to complete the square inside the square brackets. The method remains the same. Halve the number in front of the x. It becomes 0.75. You then square it and take it away. Grab your calc, square it, you get 0.5625. Let's crack on. We need to expand just the square brackets. It's 2 times all that. And it's 2 times all that. Reaching for the calculator, it's minus 1.125. And now we bring that minus 20 into play, because finally they need to be simplified. And we get minus 21.125. And I should have wrote that in there, but I can't be bothered because I'm finally done. And finally, part B. C, D and E are attempting to sketch that graph. Now, if you were attempting to sketch a quadratic graph, you'd plot some coordinates, and the 2 most important coordinates would be the solutions. So the solutions, we're going to write in this place here. The negative solution will come from the positive bracket. It'll be negative 4. And the other solution will be positive 5 over 2, which you might have written as 2.5. But again, no one cares. Which first of all means Eve's sketch can't be right, because she's got 2 solutions, both of which are negative. Can't be right. So out of C and D, whose is most accurate? Because they've both got a positive solution and a negative solution. But the key really is negative 4 will be further away from the y-axis than 2.5. As you can see on Dev's sketch, whatever value there, it's closer. That distance there is smaller than that distance there. That's why Charlie's sketch is definitely the most accurate, and I would put x equals minus 4, x equals 2.5. They are closer to the values they've used for the solutions, or any words or phrases you prefer to that effect. But it's not the worst way to end a paper. There was much trickier before then. But overall, again, I don't think this set of 3 papers was the worst. Each paper, was pretty average for me. Couple of really tricky ones, couple of ones you might not have been a big fan of, but nothing major. Mostly pretty fair down the line. If you get one of those papers in the summer, you can just say, oh, fair dues, I'm okay with that. Anyway, hope that's helped. Might just see you on the next one. Ta-ra.